So, what is the difference between function and functional? That we need to understand. What is the difference between between objective function and objective functional? Now, when you are trying to, this objective function is basically relevant, as I said, in case of static optimization. For example, when you are maximizing u equals to u function x and y subject to px into x plus py into y equals to I. So, here you are getting x star and y star, and that will lead to u star. Now, if you look at these x star and y star, if you put, then you will get u max, right. So, that means here x star and y star is some amount of quantity, maybe 5 unit of x and 10 units of y, and this is also some amount of utility which can be measured. So, that means in case of static optimization, this case of static optimization, there is a, this is a point to point mapping, point x star y star is point to point, mapping. Okay. So, static optimization basically involves point to point mapping. So, that means I have purchased 10 units of x and 15 units of y. This 10 and 15, these 2 points actually one particular consumption bundle is mapping towards another particular utility. So, that is called point to point mapping. That is why this is called objective function. So, this maximize u, this is called objective function. But here in the context of dynamic optimization, if you look at, if you go back to the diagram, what we are mapping here? We are actually mapping a path, this A, B, C, D, E and Z, we are mapping a path to a real line. We have several paths to achieve this terminal state. So, that means this Z is basically the sum total of this path, that means integral value of this path. You have invested different amount at different time period, and at the end you are getting Z. So, you can think Z is basically the integral. So, what you can say, Z is basically the integral value of different paths. What are the paths? A, B, C, D, E, Z, A, P, Q, R, S, Z, A, X, Y, W, V, Z. So, these paths are actually mapping in a real line. This is the real line where we are achieving Z amount of capital stock. So, obviously, we can think that Z is the integral value of different paths. So, that is why in dynamic optimization, we are mapping a path to a real line. So, in dynamic optimization, what is happening? We are mapping a path. For example, let us say let us say this is let us say in this axis we are measuring t, and here this is the initial state A. So, this is a path which is denoted by let us say y1 t, and let us say this is a real line. Okay. So, this value goes to V1, let us say V1. Then we have another, we may have another path, okay, and if you map this, then this goes to V2. Let us say this path is y2t. Okay. So, we are basically mapping the path into a real line. If you follow this path, then you are achieving V1. If you are following this path, this is also from here, you are achieving V2. This is a real line. There are different numbers V1, V2, V3 like that. Okay. So, here that means in case of dynamic optimization, in case of dynamic optimization, we are mapping a path either y1 to y1t or y2t to a real line, okay, a real line which is basically V. So, real line, that means what is that real line? V of y t. So, V of y t is basically the integral value of this path, okay, where y t indicates path and V of y t indicates the integral value of the path. Now, this V of y t, it looks like a composite function, okay. V of y t, that means if you think of this V of y t and let us say you are thinking of g of f x, they are not same, okay, they are not same. Here basically what we are saying, g of f x is a composite function, but this is not a composite function, rather this is the integral value of y t. You understand? Here g is again a function of f x. So, ultimately g is also a function of x, but here I am not saying v is a function of y t, y is a function of t, and thereby v is also a function of t. No, rather I am saying v is basically the integral value of y t, total y t is mapped into the real line. So, here this is a composite function, but it is not, this is not a composite function. Okay. So, do not get confused with this v of y t and do not think it is just like g of f x. g of fx is a composite function where f is a function of x, g is again a function of fx. So, ultimately g is also a function of x. Here v is only a function of yt. That means, we can only say v is the integral value of yt. Which path you will select, depending on that we will either get v1 or v2. That is why v is a function of y1t or v2 is a function of y2t. Okay. Now, from this discussion it may look like, from this discussion it may apparently, we may apparently feel, we may apparently feel that 0a, that means the initial state, and Tz are fixed, but that is not the case. Okay. 0a and Tz, in this example what we have assumed, that is basically a specific example, okay, specific example. But this is not the case. Either t or z or both can, both may vary, may be variable. In dynamic optimization. And depending on whether t or z or both are variable, we will get different context. So, in dynamic optimization, in dynamic optimization there are a number of alternatives. There are a number of alternatives regarding the terminal state or terminal situation. Terminal situation. So, let us take example. So, you are starting with here 0a, and let us assume that my t is fixed. This is t is fixed. Okay. So, t is fixed here. It is only, let us say 5 years, 10 years or 15 years. Now, in this terminal state, I am telling you that you start with a amount of capital stack. I am giving you 5 years time and you achieve wherever you can. So, if t is fixed, then what is the variable here? You can achieve either here, which is z1, you can achieve here, which may be z2, or you can achieve here, which is z3, right. So, depending on which particular path will select, how you will invest, you will achieve at z1, z2, z3. In the previous case, that is a standard example where t and z both are fixed. I have given t years time, I am telling you that this z amount of capital stock, and then you are selecting your by way of your decision variable, you will achieve that terminal state T z, you are trying to minimize this. But here our objective is T is fixed, and depending on how we will travel, you will achieve a Z1, Z2, Z3. So, we have to see that depending on the values of Z1, Z2, Z3, what is the maximum where we can achieve at minimum cost. Okay, this is one example. Let us say there is another example where Z is fixed, T is not. So, this is let us say Z, and you are starting from here. So, everyone will achieve Z only. Okay, Z is fixed. So, what we need to do is, in this axis this is time. So, I will select that path that minimizes time. So, which path should I select so that I can achieve the terminal state of capital at minimum amount of time? That might be also a case. So, the standard case what we have discussed there is this 0a and T z. So, here both T and Z are fixed. So, that is why you are selecting several paths. Like this. There might be another case where basically both T and Z are variable. So, we will not discuss this case actually. So, we will generally take the simple case where T and Z both are fixed, but you must keep in mind that this is not the only case in dynamic optimization. Depending on your objective, we may get several cases. So, that means there are different types of terminal situations in dynamic optimization. Okay. So, that means this today's discussion basically gives you a basic starting point of dynamic optimization, which is quite different from the static one. In static optimization, basically we are trying to optimize at a single time period. If it is a consumption, then we are basically trying to optimize the consumption of x and y so that our utility is maximum at that point of time. But if you think of you are maximizing a lifetime utility, then each and every time period we need to optimize our consumption bundle so that at the end of your life you feel that my lifetime utility is maximum. So, that lifetime utility maximization requires dynamic optimization technique. Okay. And the example what we have taken in an economy starts with the initial stock of capital, wants to achieve terminal stock of capital, and decision variable is investment at each period of time, at each year, so that I can achieve the terminal state of capital at minimum cost. Then we discussed about some important elements of dynamic optimization, which are initial state and terminal state. Then a decision variable. Okay, we must always identify what is the decision variable. In this case, the decision variable is how much to invest. in the context of utility maximization, how much to consume, okay, how much to consume. So, these are all decision variables. When this is a resource, let us say you have 1 barrel of oil or 1 ton of coal, the decision variable would be optimum rate of extraction. At each period you want to extract some amount of resource, so that your intertemporal benefit that you derive out of that resource is maximum. Okay. At each year you have to decide whether you need to extract 5 ton of coal or 10 tons of coal, depending on the market conditions, so on and so forth. Depending on the market condition, you need to optimize at each and every period, so that at the end the sum total of the benefit is basically maximum. So, you need to have a decision variable, then there are different paths to achieve the terminal state, and we must have one objective functional, which is quite different from objective function. Objective function is relevant for the static optimization, but objective functional is relevant in the context of dynamic optimization. Since static optimization is a one shot game, there basically you are mapping a point to another point. Depending on your x star and y star, you will achieve at u star, which is point to point mapping. But here in the context of dynamic optimization, you are basically mapping several paths to a real line. I will select that path, whether this path or this path or this path or this path, depending on my terminal state. So, that means which path will help me reaching Tz at minimum cost, okay, minimum cost. So, that means here in terms of this diagram, you can easily understand, here you are mapping a path to a real line. Depending on the values of V1 or V2, I will select either Y1t or Y2t. So, that is why here it is V of Yt in the context of dynamic optimization, which is quite different from g of fx, that is what I said. While g of fx is a composite function, because f is a function of x and z is a function of fx, so ultimately z is also a function of x, which is not the case here, because here I am mapping the entire Yt, the entire path, to a real line. So, this is basically the introduction to dynamic optimization, and the reference for this would be, first one reference is elements of dynamic optimization by Chiang. But the textbook for dynamic optimization is mathematically quite involved, okay, mathematically quite involved, little difficult to understand. That is why what I will do, I will try my level best to collect the specific information from that Alpha C. Chiang and another book to make it more lucid, which you can understand easily. So, that is why for this dynamic optimization, discussion on dynamic optimization, I suggest you fully concentrate on this and try to understand from my lecture only. Once you are thorough with this lecture, then you can just look at this Chiang's reference on elements of dynamic optimization. But this technique you must learn, which would be useful in your future career. Okay, this is a quite interesting and useful technique, but difficult to understand from a textbook. That is why please follow my lecture. Wherever you have doubt, please ask me then and there. Thank you.